This video is just a sample of what's available in the free DPE University Learning Centre. Head over to DPE University to take the full course, earn a certificate, and unlock your potential with Develocity. You can find links in the description below. Now, let's explore what is a build scan in How to Use Build Scan. In this chapter, we're going to look at what is a build scan. We'll see what is a build scan. We'll take a guided tour of an individual build scan. We'll talk about what a build scan is useful for, and we'll see when you'd use a build scan. At the end of this, there'll be an exercise for you to see if you've remembered anything from the lesson. First, what is a build scan? Initially, the build scan looks like the console output from running a build. This build could be something which ran locally on your laptop or on your computer, or it could be something that ran in a shared environment like a continuous integration server. The build scan shows much more than the console output from running a build. It shows everything that's relevant for understanding a build that you've run. Was the build successful? If not, what were the failures? Which build tool was used? Which version? What other dependencies were needed? Which tasks or goals were run? What was the infrastructure running the build? Which operating system was it run on? The build scan is a persistent, shareable record of what happened when a build was run. This is useful when the build is run in a CI environment, where you don't always have access to the details of how or where the build was run. You don't always know which operating system it ran on, or which versions of Java it used, for example. With a build scan, you can see all of that in one place. When the build runs in your local environment, the build scan is a really useful way to share the build details with someone else. You can give a link to the build scan to other people. This is useful if you want to show someone else some specifics of a build on your local machine, or if you need help troubleshooting problems with your build. Without a build scan, if you run a build locally and it fails, it can be difficult to show someone else the problems you're having with the build. Another thing that's nice about a build scan is the information is displayed consistently, even between build tools. You can produce build scans for Gradle, Maven, SBT and Bazel. Gradle and Maven have the most fully featured support, but build scan functionality is constantly evolving for all build tools. Regardless of the build tool you're using, the information available on the build scan is shown in a similar way, so you don't need to be familiar with each individual build tool to get a sense of what's happening in the build. The best way to talk to you about what a build scan is to show you one. This is a build scan for the Groovy language, which is an open source Apache project. The Apache Software Foundation has an instance of Develocity, which many Apache projects are publishing their build scans to. This is a public instance, so feel free to look around it. In this build scan, we can see the version of Gradle which ran the build. We can see which version of the plugin it's using to talk to the Develocity instance. We can see the date and time. This build scan has tags, which state things like which Git branch it was on, and whether it was a CI build or a local build. It also has links here to things like the GitHub Actions build, the sources, and so forth. These tags and links are added by the Common Custom User Data plugin, which you can add to your build to show this extra information in your build scan. You can use this plugin to add your own custom data on top of the default information in a build scan. The build scan contains much more information than just this, of course. The build scan contains the outcome of the build. For example, did it fail? It shows the use of any deprecated build tool features if you're using Gradle. It shows the tasks which were run for Gradle and the goals for Maven. It shows the total build time, which can help with figuring out the performance of the build. It can show the tests which were run. It shows the projects which make up the whole build. It shows the dependencies which were used during the build, and the dependencies of the build tool itself. It shows the plugins that were used by the build tool, and any custom values that were used. these summaries are truncated. If you want to drill in and see the full details of the tasks or the dependencies, for example, the link at the bottom of the summary will take you to a page which shows you all the information. Near the bottom of this first page, you can see switches, for example, whether the build was using the daemon, and the infrastructure it was running on, like the operating system, the number of CPU cores, and so on. On the left-hand side, you can see you can drill into a lot of other information. Some of these links take you to the relevant part of this summary page. For example, infrastructure and switches both take you to the relevant part of the summary page. But some of them show you more information. For example, this link here, Explore Console Log, is the same as pressing on the console log here. On the console log, we see the familiar output that we would normally see if we were running this on our local machine. We see the output of running the build itself. We'll go into each of these areas in more detail as we go throughout the course. In this case, all I want to do is provide you with a high-level view. We can see any failures. We didn't have any failures in this build. Any use of deprecated features in Gradle. The timeline we will definitely talk about in a lot more detail in one of the later chapters of this unit. The Performance tab shows lots of information which is useful for figuring out the performance of the build. On the Tests tab, we see all of the tests which were run, whether they passed or failed, and we can find out a lot more information about these tests which were run. This shows you all the projects in the build. The Dependencies tab lets you drill down to all the dependencies which are used. Build Dependencies lets you drill down to all the dependencies that were used by the build. Plugins shows you a list of all the plugins used by the build. And Custom Values are all the custom values for the build. This looks like a couple of pages of relatively simple information that you might normally be able to get by looking at the console log on your laptop or on the CI build, or by poking around and finding out which command was run. In actual fact, there's a lot of information presented here in the build scan. What's more interesting is the way that the build scan is presented allows you to filter, search, locate things that are interesting to you depending on what is the most important thing to you about this build. And that's what we're going to look at in later sections of this unit. Gradle provides free build scans for Gradle, Maven, and SBT, and you can generate build scans for Bazel if you're using Develocity. If you're using Develocity, you also get build scans for Gradle, Maven, and SBT. The build scans have very similar types of options, regardless of which build system you're using. The most fully featured build scans are Gradle and Maven, but SBT and Bazel also provides information like the kinds of failures that you might see when you run the build. So what is a build scan useful for? The build scan is useful for seeing all of a build's details in one place, whether the build ran on CI or whether the build ran locally. In CI, this can be very helpful for pulling together information from a range of different places. For example, which infrastructure did it run on? Which command was used to run the build? How was the build put together? Which plugins did it use? Which flags are enabled? With a local build, you can see all of that information too, which is also helpful. But often we do have visibility over what runs and how it runs when we're running a build locally. What's really interesting is the fact that we can actually share this information with other people. So, not only do we get visibility of how the build ran, what the output of the build was, what were the inputs and outputs to that build, we also have visibility over a build's performance. Again, perhaps something we take for granted if we run a build in CI, but what we don't normally get is visibility of our local build's performance across the team. So for example, I can see the performance of a build that I ran on my laptop, but my colleague can also see the performance of their build. And if you can compare this information, you start to gather a lot more information about the performance of the builds for your team. And of course, we mentioned that we can share a build scan and we can share its details with someone else. This is particularly helpful for troubleshooting. If you're creating these build scans in Develocity, you can also compare your build with another build, for example, the build which happened beforehand or the build which happened afterwards, and you can look at your build scan in relation to other builds that ran. We talked a bit earlier on about how we can look at our build scan and our team members' build scans. Imagine if we're all publishing build scans, we can see trends, patterns, and perhaps any anomalies on things like test failures, build failures, the performance of the build, and so on. Having all of this information centrally in Develocity, for example, allows us to see patterns and trends that we wouldn't normally see in our builds for the team. In short, build scans supercharge troubleshooting. In the next few chapters, we're going to look at how we can use build scans to troubleshoot and what kinds of problems they can expose to us. Now you have a sense for what a build scan is, I encourage you to go away and have a look at one. You could, for example, go to ge.spring.io, which lists a number of build scans for the Spring projects, and select one of these to take a look at. For example, we could look at this one. And then have a click around, see what you can see, and explore this build scan. I want to give you a couple more tips before you go away and do that, in case you find these helpful. Firstly, this link here allows you to share something. You can see it changes the URL. We will talk about this more in a later lesson. Secondly, on some pages, you'll be able to find a magnifying glass, which is the search or the filter. So you can play around with using search and filter on these pages. And thirdly, you'll also see this question marks on the page sometimes, and this gives you a hint for what a particular field or value means. Sometimes you can hover over to see the information. Sometimes you click on it to see the information. So go away, take a look at a build scan and see what sort of information you can see on one of these build scans. Thank you so much for watching this lesson on what is a build scan in How to Use Build Scan. Again, the entire course is available for free on DPE University at dpeuniversity.gradle.com. Click on the DPEU icon to get started and subscribe to learn more. We're excited to see what you build and test.